Welcome to NSMO, the National Science and Mathematics Olympiad. In this lesson, we will study one of the fundamental principles used to write electron configuration, known as the Aufbau principle. This principle explains how electrons are arranged around the nucleus of an atom in its ground state. Meaning of the Aufbau principle. The word Aufbau comes from the German word Aufbauen, which means to build or to arrange. The Aufbau principle states that each electron occupies the lowest available energy level before moving to the higher energy level. In other words, electrons fill orbitals in order of increasing energy, starting with the lowest energy sublevel and progressing upward. Explaining the diagram of Aufbau diagonal rule. Diagram shows us the order in which electrons fill orbitals inside an atom. Even though orbitals are grouped by energy levels n equal 1, 2, 3, electrons do not always fill them in simple row by row order. Instead, they follow a special pattern called Aufbau diagonal rule. What the rows mean n equal 1, 2, 3? Each horizontal row represents a principal energy level labeled by n. N equal 1, first energy level, n equal 2, second energy level, n equal 3, third energy level, and so on. As n increases, the energy level becomes farther from the nucleus and has higher energy. What's the letters mean? S, P, D, F. Each energy level is divided into sublevels. S sublevel, B sublevel, D sublevel, and F sublevel. These sublevels have different energy even if they belong to the same energy level. Why the arrows are diagonal? The arrows show the actual order electrons follow when filling orbitals. Electrons always fill the lowest energy orbitals available, even if it belongs to the higher energy level. That is why we follow the arrows diagonally, not straight across. For example, 4s fills before 3d, 5s fills before 4d, 6x before 4f. This happens because s orbitals are lower in energy than d and f orbitals in nearby energy levels. How to read the diagram step by step? You start at the top and follow the arrow downward. We start with 1s, 2s, 2b, 3s, 3b, 4s, 3d, 4b, 5s, 4d, 5b, 6x, 4f, 5d, 6b, 7s, and so on. This ordered exactly how we write electron configuration. Electrons behave the same way. They always choose the lowest energy position first, not the nearest row number. Why this diagram is important? This diagram helps us write correct electron configuration, understand why 4s fills before 3d, avoid common mistakes in exam and Olympiad, connect electron configuration with the periodic table. If you remember, follow the arrows, you can always find the correct filling order. Let's apply the Aufbau diagram to answer an important question. Which sublevel has a greater energy, 4D or 5B? According to the Aufbau diagram, the 4D sublevel has lower energy than the 5B sublevel. Therefore, 4D fills before 5B. This shows that energy ordering does not depend only on the principal quantum number. Characteristic of the Aufbau diagram. The Aufbau diagram helps us determine the correct filling order of sublevels, compare energies of different orbitals, avoid common mistakes when writing electron configurations. It's especially useful when dealing with transition elements and higher energy level. Writing electron configuration using the Aufbau principle. To write an electron configuration correctly, identify the atomic number, count the number of electrons, place electrons into sublevels following the Aufbau order. Do not exceed the maximum number of electrons per sublevel. S sublevel 2 electrons, B sublevel 6 electrons, D sublevel 10 electrons. The table here summarizes the key characteristic of the Aufbau diagram, which help us understand how electron energy are arranged inside an atom. First, notice that the statement, all three 2p orbitals are of equal energy. This tells us orbitals belonging to the same sublevel, such as the three 2p orbitals, always have equal energy. This is true for any sublevel. All s orbitals are equal to each other. All p orbitals are equal to each other, and so on. Next, the table shows that the three 2p orbitals are of higher energy than the two s orbitals. This means that within the same principal energy level, sublevels do not have the same energy. In multi-electron atoms, the energy increases in order S, B, D, F. The table then gives an example for n equal 4. It shows that the order of sublevels is 4s, then 4b, then 4d, then 4f. This reinforces the rule that within an principal energy level, electrons fill sublevel in the order S, P, D, F, from lowest to highest energy. Finally, the table explains an important overlap rule. It states that the 4s orbitals has lower energy than the 3d orbitals, even though 4s belongs to a higher principal energy level. This is why electrons fill the 4s sublevel before the 3d sublevel in the Aufbau diagram. So this table helps us to understand why electrons fill orbitals in a specific order, and why the Aufbau filling order sometimes crosses between different energy levels. This table shows the maximum number of electrons that each type of sublevel can hold, and helps us understand how electrons are distributed within an atom. Each energy level contains different sublevels, and each sublevel has a fixed capacity of 4 electrons. The sublevel S has one orbital, and each orbital can hold 2 electrons. So an S sublevel can hold a maximum of 2 electrons. The B sublevel has 3 orbitals, and since each orbitals hold 2 electrons, a B sublevels can hold up to 6 electrons. The D sublevel has 5 orbitals, so it can hold 10 electrons. The F sublevels has 7 orbitals, so it can hold up to 14 electrons. This explains why, when writing electron configuration, we never place more than 2 electrons in an S sublevel, no more than 6 electrons in a B sublevel, no more than 10 electrons in a D sublevel, and no more than 14 electrons in an F sublevel. This table is essential because it prevents overfilling sublevels and ensures that electron configuration follows the Aufbau principle, Pauli exclusion principle, and Hund rule. Now, let's move to solve the exercise. Distribute the electron of sodium atomic number 11, taking the Aufbau principle into account. Sodium has an atomic number of 11, so it has 11 electrons. We fill the orbitals in order. 1s2, 2 electrons total 2. 2s2, 2 electrons total 4. 2b6, 6 electrons total equal 10. 3s1, 1 electron total 11. So, the electron configuration of sodium is 1s2, 2s2, 2b6, 3s1. Shell energy level form. Sometimes electron configuration are written in shell form, showing how many electrons occupy each main level. For sodium, first shell n equal 1, 2 electrons, second shell 8 electrons, third shell n equal 3, 1 electron. So the shell configuration 2, 8, 1. Importance of the Aufbau principle. The Aufbau principle is essential because it explains atomic stability, helps predict chemical behavior, forms the basis for predicted trends, is used in nearly all electron configuration problems. Although there are a few known exceptions, the Aufbau principle applies to the vast majority of elements. Conclusion: the Aufbau principle tells us the electron fills the lowest available energy levels first. By using the Aufbau diagram and following the correct filling order, we can accurately write electron configuration for atoms in their ground state. Thank you, and with my best wishes for success at NSMO.